Oh, no way.
Don't put words in my mouth. You hear that?
I don't think I started my homework yet.
Miguel, control yourself. Noah, don't antagonize him. All right, 35. Nope, that's not 35. Oh, 30. All right, what's the volume of a sphere? Somebody get 4/3. All right, so it says, what's the rate of change of the volume of a sphere with respect to the radius when the radius is 2? So that's an instantaneous thing, right? When r equals 2.
I'm submitting the homework that I scanned in last night.
Logan is not an exception to the rules. Go put your phone in the pocket. All right, limit as h goes to 0. No, it's supposed to be due at 8. I'm doing F, but speaking of, and let me just take a minute to speak on this for 1 second. I'm actually going to change this for the sake of example. In grading your tests, a lot of you missed points, and we're going to take some time to talk about them. We might not have time today. It might be tomorrow. A lot of you lost points for some really, not lost points, because on AP you just gain points. You don't lose points. Really silly things. Like they said, why is g of x continuous? And you said g of x is continuous because the limit as x goes to whatever it was, of f of x equals f of whatever it was. And it said g of x. At least 3 people did that, where you didn't name the function correctly. Yeah, they're in. No. No. Check on your computer. Yeah. All right. I just wanted to speak on that really quickly, because be very careful about things like that, because the grading on AP is very specific. If you have this, you get this point. If you have that, you get this point. So a lot of you, that's why your FRQs were not as strong as what they could be. Yeah. This is always IROC, and that's your X. That's exactly right. Yeah. That's a point. Yeah, that's meters. That M is meters. That's 1.86 t squared meters with 2 seconds. Yeah, sorry. That was a little confusing. I'll give you that. All right, so I'm going to come over to the side. I'm going to do V of 2 plus H. 4/3 pi. Ooh, no wonder y'all didn't like this one. Thank you. Did you do it this morning? Did you do it this morning? Thank you, Logan.
And I didn't turn it in this week.
All right, let's see, times 4. 8 plus 4H plus 8H plus... I did a FOIL on those two first. 2H plus 2H plus 8. Did I do it wrong? Okay, so I multiplied everything by 2. Oh, it should be 8. Is that what you said? Is that what you're saying? Wait. I did. I don't know what I did. 8 plus, yeah. Oh, I distributed the other way. I did 4 times. Then I did 4H times. And then I did h squared times, yeah. I just did it in a different way. Shh. I'll tell you that. What trinomial are you looking at? I FOILed out 2 plus h first. I just did it in my head. I didn't. It's 3 times. All right. I think that I'm going to leave this like this and see what cancels. Let me see what v of 2 looks like, and then I'll decide. 4/3 pi times 2 cubed, right? 2 cubed is 8. 32 pi over 3. Is that right?
What?
Which is what you're going to get here. Okay. This is just really nasty, but it's not, I mean, I'm going to go ahead and distribute so you can see, because I know y'all are going to ask me questions if I try to. 16 pi, yes. We still got a while before we talk about that. Why didn't I combine those like terms there? All right, do y'all need this or no? Because I got a lot of other conversation going on. If you don't need it, that's fine. I don't need it either. I'm going to let me put this in standard form. So it's a little 6h squared plus, is this what y'all got? 4h cubed over 3 pi plus 24h squared over 3 pi plus, oh look, that simplifies, that's 8. This also simplifies from 16. Is that right? Yeah, 8h squared pi. And then plus 32 over 3 pi. And I did all that because I really wanted you to see that whenever I plug in this formula, remember it's this minus this over 8. I'm not going to rewrite it because I don't want to. That cancels, and I can take an h out of everybody. H, 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 H. So I end up with 4h squared over 3 pi plus 8h pi plus 16 pi. Remember, I'm doing the limit as I go to 0, which just gives me 16. That's not wrong. What? Oh. Cubed inches per inch. Wrong. Is that what you said? No. Because it's a rate. Gotta have the per in there. Alright, what else? 35. 35, and then we're going to move on to the quiz. Shut up, Logan.
I know that one.
Find an equation for each, notice it says each, Logan, each tangent to the curve, y equals 1 over x minus 1, that has a slope of -1. So this is a little bit different, Logan, than what we've been doing, because instead of finding the slope at a specific point, they're asking you where this happens, right? Does that make sense? So what I'm going to do, I know that slope of a tan line is found by doing the limit as h goes to 0 of, this time it's y, so y of x plus h minus y of x over h. Yes? And I need this to equal -1. Right? So I've got an equation that I'm going to solve for x. But let's plug in. All right, so now I've got the limit as h goes to 0 of 1 over x plus h minus 1. Yes. Minus 1 over x minus 1. Everybody goes over h. I can't plug in, which is what I want to do. So instead, I start manipulating. Ooh, doggy. Okay. I'm going to give this one an x minus 1. I'm going to give this one an x plus h minus 1. Because you can't just add something to it. You can only multiply the denominator. This is why we're... It's a quadratic. It's not a rational. All right, so I've got the limit as h goes to 0 of x minus 1 minus x plus h minus 1 over that common denominator. And I'm going to go ahead and do 1 over h. All this equals negative 1. Well, I've got to solve it for x. Up top, the x's are going to cancel. I've got negative 1 minus negative 1, which is going to cancel. This h that was in the bottom. All right, so I've got limit as h goes to 0 of negative h over x minus 1, x plus h minus 1 times 1 over h. You absolutely 100% can. And I get the limit as h goes to 0 of negative 1 over x minus 1 plus h minus 1. Can I plug in a 0 for h now? I can. So this is negative 1 over x minus 1, x minus 1. Can you solve that for x? Yes. Yes, you can. I put a 0 in for h. Okay, I would do the same. Make it x minus 1 squared. Both sides are negative. Can I do that? Did I multiply both sides by negative 1? Drop those negatives?
So me, I can.
Negative times a negative. Can I multiply both sides of any equation by the same thing ever? If they're both. Is it? What does x equal? No, not yet. Square root that thing. No! You can share calculus, bro. No. Not like this, no. No. You don't have any horizontal tangents or anything on there. I'll find any places where it is. if I flip both sides, I still end up in the situation of this, and then I can just add 1. So I get plus or minus 1 plus 1. So that would mean
Just get rid of the top of the fraction.
1 over 1. Cross multiply if that doesn't make sense to you. Always the algebra. What do you mean? Like where you plug them in? Okay, so you're going to find that in these, and that's why I always give them to you, but they're going to do them, in my opinion, a little bit harder than what we do. Okay. Davis, is there anything I can do to make your life easier, buddy? Okay. All right.
I'm checked out.
Assume a rock is dropped from the top of a 200-meter cliff. Find the velocity of the rock at 1 second. Okay, this one makes no sense. Instead of dropping a rock that many meters, you threw the football that many meters. How fast was it going after or at exactly 1 second? It's the same problem. Didn't have to what? This is your equation. But it's when t equals what? 1. So the limit as h goes to 0, s of h, right. What? This is just the setup. I haven't put it. S of 1 plus h is 1.86 times 1 plus h squared.
Stop.
Oh my goodness. Stop. No, where did I lose you? What's your difference quotient? Tell me the difference quotient in general terms. The limit as h goes to 0 of f of x plus h. This time it's not f, it's s. And instead of x, it's t, but it's when t equals 1. Go with me now. Say again. Okay, that is literally s of 1 is just, yes, that's putting that in for that variable. Did you what? You haven't watched film in AP Bio?
That's all I do. But it shows that I haven't done anything. Like, I don't have any time. I sat there and watched it for an hour.
What's 2 times 1.86? All right, I'm going to plug in limit as h goes to 0 of 1.86, don't touch me, Logan, plus 3.72h. This is the satisfying part of these kind of problems when you start canceling out.
That's my favorite part.
That's my favorite part. Not 3.72. There you go.
Oh, yes.
What you need? No, what you need? Which one? What is A-Rock? What's the difference in A-Rock and I-Rock?
I think really it is.
Possibly. Okay, let's say. Okay, not necessarily. And so for average rate of change, you need a span of time, right? Instantaneous rate of change is at this point in time. It's just 1 point. Average rate of change spans because it's an average, so you need 2 endpoints. So what if I said, take this same problem and tell me what is the average rate of change over the first 2 seconds?
Go to Y or go to X.
Right, but if I'm going over the first 2 seconds, that's exactly right. I would need to know at t equals 0 and t equals 2 what those values are. Well, if I plug in 0, I get 0. If I plug in 2, I don't know what I get. 4 times 1.86. Okay, Sunny says 7.24. So for the average rate of change over this interval, it would be, but your units are still the same as what it was, yes, Noah, as what it was before, which was meters per second. Slope. That's it. A-Rock is always slope, I-Rock is always difference quotient. If they tell you the rate of change at a point, that is I-Rock. If they say the average rate of change, that is A-Rock. Yes, you are. This is the new packet, yes. This is moving on to the new packet. All right, derivative of a function, you're going to like this because... Yes, this is the new packet. You don't need it right now. All right, derivative is nothing more than a fancy word for the slope of the tan line. And we're going to be doing the same thing that we've been doing, okay? So, instead now, we're going to use this notation we talked about before, f prime of x. That lets me know that it is the derivative or the slope of the tan line. And it is defined as, what? No, not yet. Not yet. No, who? Said these were the worst things ever? What, difference quotient? Is that who told you about the power rule?
I saw all the video and it said I didn't have to use different.
You don't with that, whenever we learn how, but. All right, limit as h goes to 0. I'll teach it to you, just not yet. Limit as h goes to 0. Give it to me. Y'all know this. F of x plus h. Only as we do it now, yeah. As we, no, don't encourage me, girls. As we do these different questions now, we're not gonna get a specific value. We're gonna get an equation. Okay, we're gonna find an equation for the derivative, or an equation for, so it's not at that specific point, and we've already done this. Remember where we worked it through and we got like 3x plus 2 or something? We could plug in any value of x to find the slope at that point, right, Logan?
Right, that's right.
Okay, what did I say?
Any value of x to get that slope of that point.
To get that slope of that point.
I-Rock, maybe, let's go.
All right, so
with it. I was with it.
Whoa, what is that?
Wow. I read that earlier. Wow, that was a cool trick.
Find, y'all ready for this?
No.
Find the derivative of f.
Oh, no way. What? The power rule said it's 3x squared.
We're not to the power rule yet.
Why?
No, because I have to teach you this first. All right, here we go.
I want to know the power rule. Why? Will you tell me what the power rule is? It's just like something that happens.
We're not. All right, listen. When it is a lot easier, but it is. If you don't know this, you are going to be missing it on the test. And I have to tell you this. Standards is tested. It's heavily tested. It is heavily tested. All right, and you'll fail your first test or your second test because you have to be able to do this. Okay. You get two. Yeah. Do what? Yeah. 2-point Mickey. All right. Remember that difference quotient, f of x plus h minus f of x all over h, yes? And I am going to plug in. Look at what I have now. I have x cubed, yes? So it's the limit as h goes to 0. Make sure you are writing the limit each time. There are times when you will get in an FRQ situation where you have to use different quotient. They will literally say, justify the derivative using the definition of a derivative. This is the definition of a derivative. If you don't continue writing limit beside it every single time, you lose your point. Okay, so make sure. Yeah, I know. It's about showing your work. Yep. I know. That's the tweak out seat, so. We'll look at it. I'll probably just tell you. Make sure you use proper notation next time. We're learning. All right. Yeah, I'll give you some. I'll give you as much as you need. It's infinite for you. All right, I'm just multiplying this out over here. Plus x squared h. I am tweaking right now. I'm doing a whole lot of, yeah, it's all the algebra part of it. Okay. Well, I haven't plugged it in yet, right? Because it's, well, yeah, I had two like terms. The x squared h's and the xh squared. I put it up. Sorry, hold on. Oh my gosh, y'all. Okay, it should be there. You should be able to see.
Oh, yeah.
Yeah. I just combined like terms. Miro should be working now. All right. Yes. I'm doing the exact same thing that I've been doing the whole time. Yep, n's gone. While we're here, take off h's. So that'll be 2, that. So I've got the limit. Remember the whole goal all the time. Same thing every single time. Can I plug in now for 0? For 8? Yes, I can. Well, what does it equal? That's the answer. No, I will not give you credit for just writing 3x squared. You have to show me all this. Yeah. Probably higher than that. I don't know. Yeah. Let's do another one. Let's do another one, huh? Nothing. It's just that now instead of getting a specific value, I'm getting an equation. So I keep the x in there. That's exactly right. Horizontal would be if I set it equal to 0 and solve for x. That was my original function, x cubed. Yeah. Yeah. What's that mean? Did you do your smart pass? Okay, all right, find the derivative. Find the derivative. Find the derivative. Whoa. One more time. Find the derivative. I'm doing that to save me time and writing in just a minute.
All I can think.
Anytime I ask you for the derivative, it's the difference question. The limit as h goes to 0. Okay. F of x plus h is the square root of x plus h minus the square root of h, square root of x, sorry, over h.
This is what I got.
So what in the world can we do?
Where?
You can't just square it because you want to.
Well, that's what I did.
If I see a radical
Conjugate.
I would definitely do conjugate here.
Maybe I should have thought about that a minute ago. Be an idiot.
Do better next time.
Stop it. Stop it. You know what I'm gonna do tonight? I've never gotten a problem.
Your homework.
Go home.
Your homework.
My homework.
Slade, do not say things like that. He didn't say anything. All right. Look. My X's are canceling. The goal each time, remember, is to plug in for my H value. Yes, I still can't do it, but I can cancel those h's, right? So I end up with the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. Now can I plug in? Yes. That's the answer. Because this will, if I put a 0 in here, it's just square root of x plus square root of x. Huh? I just did the square root, but I changed the middle sign. That's it.
So you can pull that out of nowhere, but when I want to clear something.
Say that again. I did FOIL it. Well, if you multiply the same square roots together, the radicals cancel out. And if I multiply by conjugates, then the middles are going to cancel. This times this and this times this are the same but opposite sign. So if you multiply conjugates, you only have to multiply the first together and the last together. Square root of x squared. All right, let me show you this really quickly, and then I'm going to stop. Write this down somewhere. This was not tested, was not a required testing part of calculus until a couple of years ago. And a couple of years ago, they started incorporating this and saying you had to know. Before, it was an alternate definition, so students like a little better. Did it. Now they will throw a random multiple choice question in there. Alternate definition. It is the same thing. What? It's the same thing as finding the derivative. It is the same thing as the difference quotient. It does the exact same thing. The difference here is your A is at a specific point. It seems that way, but it's not always that way. Alternate definition. You could have used it on the last problem. It's really more, it's more beneficial using it at a specific point than it is because your A is at your specific point. All right. Here's what I want you to do.